In this video, we're going to talk about solving systems of equations using substitution. By the end, you should be able to solve a systems of equations using the substitution method. Remember, substitution is that when two things are equal, they can be freely substituted or switched out for one another, such as substitute players in a basketball game, to give the other player a rest. The steps for substitution are going to be, you're going to choose one equation and you're going to solve for one of the variables, either x or y. To determine the equation that you want to choose, you pick the one that's easiest. Again, the goal is to have one of the equations have a variable that's by itself, so that you can plug that part of the equation into the second equation, into the one that you haven't changed. You're going to distribute, combine, and solve. So once you substitute it in, you'll distribute, you'll combine like terms, and then you'll solve the equation for the variable. Once you solve for that given variable, then you'll plug that answer back into one of the two original equations and solve for the remaining variable. Remember that there are three types of solutions that we can end up with. Those three types of solutions are one solution, no solution, and infinite solutions. Looking at the following example, we have the equation 3x minus y equals 4 and y equals 16 minus 2x. Because this equation has y by itself, I don't have to change anything, but what this tells me is that y is equal to 16 minus 2x. So because y is equal to 16 minus 2x, it allows me to be able to substitute this given expression into the y into the other equation. So I can write a new equation that says 3x minus, and instead of y, I'm going to write what y is equal to, and y is equal to 16 minus 2x. And then that is equal to 4. This allows me to be able to solve the equation for x, whereas before I could not do that. So 3x, I need to distribute the minus sign across the parentheses, so this would be minus 16 plus 2x equals 4. Combine like terms, so 3x plus 2x gives me 5x minus 16 is equal to 4. When I add 16 on both sides, this gives me 5x is equal to 20. So that says x is equal to 4. So now that I know what x is, I can use x to find y. So remember, you plug it into one of the two original equations. So I'm going to plug it into the second equation here, as that one seems just a little bit easier for me. So instead of 16 minus 2x, I now know that x is 4, so I can substitute in 4 for x. So this is y equals 16 minus 2 times 4, or 16 minus 8. And so y is equal to 8. So I know that my x is equal to 4, and my y is equal to 8. Again, we have equations such as 6x minus 2y equals negative 4, and y equals 3x plus 2. Y is by itself here, so I don't have to change either of the two equations because I already have a variable by itself. What this tells me is that y is equal to 3x plus 2. And so in the first equation, I can substitute in 3x plus 2 in for y. So instead of 6x minus 2y, I'm going to have 6x minus 2 times 3x plus 2, and all of that equals to negative 4. Again, distribute the negative 2 throughout the parentheses, so this would be 6x minus 6x minus 4. So negative 2 times positive 2 is negative 4, is equal to negative 4. What happens here is that these get canceled out. 6x minus 6x goes away. We're left with negative 4 is equal to negative 4, which is a true statement. So this tells me that I have infinite solutions. Anytime the variables get eliminated and what I'm left with is a true statement, that tells me that I have infinite solutions. Looking here, we have 3/5 x equals y, and we have 3x minus 5y equals 15. What I know is that y is equal to 3x, or 3/5 x, and so I can plug that in for the y in my second equation. So instead of 3x minus 5y, we're going to have 3x minus 5 times 3/5 x equals 15. When I simplify, this is 3x. Negative 5 times negative 3/5. The 5's there cancel out, so what I'm left with is negative 3x is equal to 15. 3x minus 3x, that goes away, so it leaves me with 0 is equal to 15. That is not true. So the variables canceled, but now I was left with a false statement. So this would be no solution. This would say that would indicate that these two lines are parallel, and so they will not have any intersection points. So no solutions. Looking at our word problem here, we have Alfred has 9 pencils and pens. He has twice as many pencils than pens. How many does he have of each? So we're trying to figure out how many pens and pencils he has. So x will be pencils. I'll make y pens. We're going to write the two equations. So our two equations that we have, if we know that he has 9 pencils and pens all together, that means the number of pencils plus the number of pens is equal to 9. Then it says he has twice as many pencils than pens. So the number of pencils that he has, x, the number of pencils that he has, x, is equal to twice the number of pens, y. So x equals 2y here. What we want to do at this point is we want to find the solution. So I can use substitution here. Again, I know what x is equal to. I know x equals 2y. So in this equation, instead of x plus y, I can write 2y plus y is equal to 9. I substitute those out. That would be 3y equals 9. Y is equal to 3. If y is equal to 3, when I go back and I check it in one of my original equations, I get x plus 3 is equal to 9. Well, the only number that I can add to 3 to get to 9 would be 6. So x would have to be 6. Now I want to check my answer for reasonableness. So I should have 6 pencils, since x was pencils, and 3 pens. I go back to my word problem. I know that he has 9 pencils and pens, so 3 plus 6 plus 3 is 9. He has twice as many pencils as pens. Is the number of pencils he has double the number of pens? And that is correct. So I know that my solution is correct. Before watching the next video, please consider the following. To solve a system using substitution, what is it that you do?